I was supposed to say one. All right, so we're live. Okay, well, my name is Jase McCarty. I'd like to welcome everybody back to another Facebook Live. Today we're going to cover, I don't know if you can see it or not, but vSAN basics. I've been told this is a little aggressive, some of the things that I want to cover, but we're going to do our best to press through them. A couple things I want to cover today are really native versus VSA in a hyper-converged infrastructure. I also want to cover one of my favorite things of all of what we do with vSAN and also vVols is storage policy-based management. And then I want to give a little bit of guidance around fault domains and kind of what they are, where you should use them, why they're important to you specifically with vSAN. So with that, I'll go ahead and get started with native versus VSA. And this is, we can look at this as kind of this particular illustration is, let's say, our hyperconverged infrastructure with VMs running on top. I'll call this native, and I'll call this one to the right VSA. Where in a VSA configuration, we've got one VM that's really providing our storage for us, right? Now, these are a little bit different. There have been some conversations specifically around data path, and in a VSA type platform, we've got to basically from the VM to the VSA to the disks and back, and people have had the conversation around, additional steps as far as the data path. I don't really necessarily subscribe to that if you size it right, per se. It is something that you do have to keep in mind. However, one of the things that's really important to me, specifically with the way that we do vSAN, being native, or in-kernel we call it sometimes, but this native capability, data services are provided directly from the cluster up to our VMs, right? Now, in a native configuration versus a VSA configuration, which is pretty much what everybody else does in an HCI platform, this VM, that's this storage VM, you can call it a virtual storage appliance, a container VM, whatever, a couple different ways of naming that, if you will. But this VM's got to compete with the rest of the VMs that are running on that particular host, right, or those hosts. With that being said, as these guys require more resources, I may have to adjust that VM. Now, there are a couple of different ways I can do that, and I may, enable hot add for that VM and other things. But important thing to keep in mind is their behavior directly impacts the behavior of the storage VM, right? Now, in vSAN, we don't really have that. vSAN is natively providing data services up to each of our VMs, right? So it's not anything that we have to tweak. It's not anything we have to change. We always have a given amount of CPU, a given amount of RAM that's being used in a vSAN configuration, and it's really all dependent on how much cache we have, how many nodes we've got, different things like that, right? But we never really have to adjust this, right? There's not anything that we say, oh, well, this VM's not really performing the way we want it. We need to tweak something, specific to the host configuration. We don't really do that. And the reason we don't do that is because it's built in, right? So vSAN's data services are really not specifically in the same path as far as these VMs go, as far as the contention of resources, right? Like a VSA type platform might be. Now, in cases such as that where we want to enhance the performance of a VN versus let's say we want to enhance the performance of a VN versus changing the resources that we're presenting via this virtual storage appliance. That's kind of where something like SPBM comes in, right? Storage policy-based management. Important thing to keep in mind is if I look at a traditional array, let's say I've got I'll call this a disk enclosure, if you will, with some drives on it. And let's say I want to carve up 4 of those drives for, let's say, a RAID 5 configuration and present that up as a LUN. I've got to do that at the back end in the storage layer, and then present that up. If I need to change that, then I may need to make let's say an alternate one, present that up, move my workload over, then destroy this, and let's say I'm not going to do RAID 5, but I'm going to change it over to, let's say, mirrored or something else, and then I move my workload back, right? Well, that's not really efficient. That's kind of where SPBM comes in, and if you look in this particular case, this is just I'll call this a data store, if you will. This is a VM, this is a VM. I can go and I can create another VM and apply a policy specifically to the VM itself, the VM home space. I can apply a policy to 1 or more disks or the entire VM. And I can say, well, I want a policy of, let's say, just mirrored. In other words, I want 2 copies, be able to protect from a single failure, or if I want to protect from a second failure, I can add another copy here, right? So I don't have to change my storage up any. That's the really important thing when it comes to storage policy-based management is I'm not changing my storage. I'm changing the way that I'm laying my VM's data out on the storage, right? So that's kind of where, to me, SPBM is magic, right? We do support SPBM with vSAN and also vVols. The important thing to keep in mind is when it comes to SPBM, it's all about individual level VM control, or really individual disk control. I can do things where, let's say I have a VMDK and I want to stripe it even further, so kind of like a RAID 1 or RAID 0 stripe, if you will. I could apply a policy that breaks that into more components and then puts it on different hosts, right, or disks, as far as my data layout. But it's, again, important thing to keep in mind, it's highly dynamic, it's all applied by policy, and it gives me more granular flexibility. And I don't have to be a storage admin to know I've got this many disks and I need to carve them this way for this level of protection and whatnot. I don't have to worry about that anymore with storage policy-based management. Now, with that being said, when it comes to the decisions that we make based on SPBM, whether we're using mirroring or erasure coding or different things like that, they really kind of fall depending on the number of hosts. If we haven't implicitly set up any fault domains, we're kind of looking at a per host basis. But we have the capability of, let's say, for instance, I want to have 4 hosts here, right? I'll kind of color these guys in. They're going to be treated as their own distinct fault domains. Now, if I add another host to each of these and I put them in a construct of 2 hosts per fault domain, as I'm applying these SPBM policies, I'm going to write data to fault domains individually. Now, if I lose a host here, this host is gone, let's say, because I don't have another host here. I'm not going to rebuild anywhere on the other fault domains because I isolate the way that I write the data across fault domains. Now, where this is kind of important, I talked to a customer not too long ago, actually it's probably been about 6 months ago, and they were consuming vSAN in this way. They would buy a rack with vSAN, spin it up, buy another rack, vSAN, spin it up, buy another rack, vSAN, spin it up. They might put those together, that type of thing, but I had a conversation with them and basically said, let's say rather than consuming vSAN a single rack at a time, let's consume vSAN across racks, right? Now, it's a good idea, and I'll be honest and say that we used the term in the past called rack awareness. There's not really anything natively aware of a physical rack boundary or power or network or whatnot. But it's important to keep in mind that as we go and deploy vSAN, as we have different physical boundaries, right? So let's say this is a rack here with its own physical network and power boundary, and put these particular hosts in a single fault domain. So if I get to the point where I am, let's say I run into a situation where a single rack is isolated, okay? As I'm meeting my SPBM policies, let's say a mirroring policy, which I have to have at least 3 fault domains. Let's say I've got some data written here, I've got some data written here, and I've got, let's say, a witness component written over here. Actually, let me back up. Let's say I just happen to be writing data here. Well, as I go to rebuild that data, I'm not going to try to rebuild in this rack that's now gone. I'm going to try to rebuild in another rack that's open. Right? So fault domains are a really important construct that we use in vSAN to be able to leverage the capabilities of SPBM, really giving us the flexibility of having multiple levels of protection, multiple levels of, let's say I'm doing striping, whatnot, levels of performance, breaking across, again, multiple physical boundaries, that type of thing, right? If we put all these together, the fact that we don't have to really do any tuning within the hypervisor natively, and the fact that we can individually control the level of performance, the level of protection, caching, whether we want to use checksums or not, maybe our application's already got checksum capabilities, that type of thing, all based on SPBM, and we combine that with fault domains to give us more flexibility and ensure that we've got data availability, data protection, and we can literally move things around as we will, all based, in a software-defined type strategy, if you will, right? Now, I don't know how am I on time. Hey, right at 10 minutes, okay. Well, I will say that you can follow me on Twitter if you have any questions, you want to reach out to me, or more importantly, I would say follow VMware, I can't write, VMware vSAN. And then also, we've got a lot of really good information at storagehub.vmware. Sorry about the writing, folks. .com. All right, so storagehub.vmware.com, VMware vSAN on Twitter. Oh, we have a question? Okay.
So what is the difference between vSAN and SAN and EMC?
Ooh, okay. So just the question that just came in now, what's the difference between vSAN, SAN, and EMC? So EMC was once a company that's now part of Dell, and they call that Dell EMC. Pardon me. And they sell, among other things, they sell VMware vSAN. They sell VMware Dell EMC VxRail. Those are both vSAN type of either software or hardware and software offerings, appliances, if you will. SAN is really an acronym for Storage Area Network, and that's typically, traditionally, what I would say reserved for things like providing services that are block-based, like fiber channel-based storage or iSCSI-based storage, that type of thing. SAN can be a scale-out system. SAN can be a dual controller system. It really just kind of depends on the model that you're looking at, that type of thing. The important thing about vSAN specifically, I think in comparison to a SAN type architecture, vSAN is really what we categorize as HCI, or hyperconverged infrastructure, where each one of our compute nodes is also providing storage as well. So storage, network, compute, all residing in the same space. Whereas a traditional SAN model will have compute here, some type of fabric, if you will, whether it be fiber channel based or IP based, and then you're going to have some type of SAN, if you will. Now again, this can be dual controller, be quadruple controller, whatnot, really just depending on the model, right? Any other questions? Okay. All right, well, again, my name is Jase McCarty. I really appreciate you guys tuning in today. If there's anything that we can do, any questions we can field or whatnot, please feel free to reach out to VMware vSAN on Twitter. Feel free to reach out to me, Jase McCarty, on Twitter. And we look forward to seeing you the next time. Thanks a lot.